Hi everybody. So I'm waiting on Amy to join us here. Oh, there's Nate. Okay. All right. So, hello wanderers. My name's Hannah. Some of you might remember me from the store like a year or two ago. I worked here with Nate and Amy for quite a bit. It was super fun. And Nate and Amy were thinking, and they decided to ask me if I wanted to be involved, and I did. It sounds so fun. To kind of repurpose the Alpine store. As you guys know, the storefront's closed here, but we've decided to repurpose this space a bit for right now. Nate and Amy and myself have always been very passionate about geology and appreciating like the natural processes and natures of the minerals that we have in the store here. We've always wanted this to be like a very educational and accessible, friendly space to explore the scientific properties behind geological processes and minerals. And so we wanted to do this series to go through some frequently asked questions, some basics, and so I will be guiding you through a couple of those things. I'm really, really excited. So the first thing that we'll cover is how do we identify minerals and crystals? And there's a ton of ways to do that. There's a lot of ways that are pretty fun. We'll kind of go through those one by one just to break it down conceptually and make it a bit more accessible to look at. Because I know when I try broaching topics, it helps to see things kind of in boxes. So I'm really, really excited to get started. The first, things to understand about identifying minerals and crystals is there's kind of a lot of little subsections for mineral and crystal identification, and we're going to cover a couple in depth. Those are going to be Mohs Hardness Scale, which I'm sure a lot of you are familiar with or heard of, and if you've not, that's totally okay. Another one is luster. That's really, really helpful when you're looking at a huge swath of minerals, or if you're outside and you're trying to rockhound or collect your own things to display in your home. I know I love to do that. Another thing is cleavage and fracture, and what's the difference between those things? Which one is more helpful? Because one is more helpful than the other one. Crystal habits and systems, specific gravities, fluorescence, magnetism, twinning. Those are all things that we start to get a little into the weeds there, but I think the Mohs hardness, the luster, and then the cleavage and fracture are probably the best to approach when you're either out in the field or you have something in your collection that maybe you can't quite remember what it is. There are going to be pretty fun little field tests that you can do to identify these. So yeah, we'll start on a Mohs hardness little breakdown, I suppose. This is like my first time doing any sort of video like this, so you'll have to bear with me a little bit. Might be kind of clunky, but I promise that I will get better at it. So for those of you who have never heard of Mohs hardness, we're just going to go through the basics of it. Is this going to be backwards? I think it is. Okay. So I wrote down a little sheet. I'm so nerdy. Of the different levels of Mohs hardness. So I'll show you guys right now. So Mohs Hardness Scale is broken up in levels 1 through 10. 1 being the softest and 10 being the toughest. So as you go up this list, a fun fact about Mohs hardness is it's actually a logarithmic scale. And logarithmic means that it increases tenfold with every single level. If you're familiar with seismographs or like earthquakes and stuff, the Richter scale is similar. So talc is our softest mineral, and gypsum is 10 times harder than talc, and then calcite is 10 times harder than gypsum, and so on and so forth. So it kind of compounds in terms of durability. This is really important in a lot of applications. Generally, when people are looking at, say, like engagement rings, they're going to be looking for really, really durable minerals. So they're going to be looking for like an 8+. This is pretty much the standard log or, handy dandy little tool for Mohs hardness. It's kind of the typical thing to look at. I wasn't able to find specifically everything that was on here, so I had to get some things that were about the same. But yeah, if you look up Mohs hardness, this is typically what you'll find. So let's get into it with the minerals. I couldn't find any talc, so I just wrote talc on this piece of paper. But talc and gypsum minerals, those two first, you should be able to scratch those with your fingernail. They're quite soft, and generally you're not going to see them in applications where they have to get wet or be durable. There's a lot of gypsum found in drywall, so it can be sturdy, but that doesn't always mean that it is hard, if that makes sense. But yeah, I put together this little table so we could visually together look at what Mohs Hardness Scale looks like. So I'm excited to show you guys. All right, so we've got it kind of going up. I also did not, I couldn't find an example for number 10 either, so I just wrote diamond. But anyway, so we'll start down here with talc being the softest. You'll be able to scratch that with your fingernail. This is selenite. This is a gypsum mineral. And this one is really, really beautiful, but very soft. You'll be able to see me. Let's find a good spot. Scratch that with my fingernail. So it's super, super, super soft. This is an example of the golden sun selenite. It's only found in Utah, so this is a really beautiful mineral, but it is somewhat soft, so we don't want to put it around things that could scratch it or harm it. The thing that makes Mohs Hardness Scale really useful in the field is that you can have different tools to differentiate levels of hardness. And so I put down little physical examples here. I couldn't find a steel nail. Funny enough, that was the only thing I couldn't find, so that's a little interesting. But we saw this example of Mohs hardness being at a 2 with gypsum minerals, which includes selenite, satin spar minerals. Your nail is at a 2.5 in terms of hardness, so that is why it can scratch up to 2, but not 3. 3 is where you start needing a copper penny to make a scratch in the material. I'm gonna get my little stand here. Hopefully it will be more stable. All right. Oops. So calcite at a 3, you can see is going to scratch, hopefully, with this copper penny. Now you can see that big scratch left by the penny. And the penny can scratch the selenite and our talc, of course. But a copper penny is at a 3.5, so it cannot scratch anything tougher than calcite or tougher than something that's on a 3. To make an example of that, I'm going to try to scratch this fluorite. And it is not, shouldn't be able to. Sometimes fluorite can be a bit on the softer side, but sorry, my nails are dirty from picking up all these rocks. But yeah, so that is unscratchable by a penny. When you get to 4, fluorite is a really good example of a 4 on Mohs hardness. When you're at a level 4 or a 5, that can be scratched by a knife or a glass plate, which sits at a 5.5. I was scared that I wouldn't be able to have a knife on camera, so I got this pair of scissors. I'm going to find a really inoffensive place to scratch this. Let's go right here. There you go. A little scratch there. So that confirms that this is Mohs Hardness 4. The next level up, generally you'll see apatite on those charts. I could not find any apatite, but a zeolite will generally sit between a 4 and a 5, and a zeolite is something that we've had in the store quite often, so I thought that that would be a pretty good example of a 5, pardon me. So you can see that we'll be able to find another inoffensive place to scratch this. So you can see that I am able to make the scratch, but it was just a bit tougher than a scratch on the fluorite. So that's important to note with the 4 and the 5. It can be like a bit subjective in terms of how you're observing it, but in general, it's a really, really useful tool for identifying different minerals. So I couldn't find a steel nail, so you just have to take my word for it for these next ones. But 6 is generally represented by an orthoclase. That's a really good example of a 6 on Mohs Hardness Scale. This is the closest example of K feldspar or orthoclase that I could find. But these two are also fairly good examples. This is labradorite and this is rainbow moonstone. These are actually like versions of the same mineral, but really closely related to orthoclase. They're both in the feldspar. They're all in the feldspar family. So if I had a steel nail, it would be able to scratch these minerals. And same with quartz. Quartz is kind of the quintessential number 7 on Mohs Hardness Scale. This one can kind of rest between a 6 and a 7, so it really just depends on how easily you're able to scratch it with a nail. Quartz is like a bit unmistakable in terms of everything it's got going on. So generally with quartz, hardness is a really good tool, but there are some other tools that we can use to identify quartz as well. When you get... Oh, wait, I made a mistake. Pardon me. Oh, no, that was right. So number 8 is generally represented by topaz. I couldn't find any of that either. But I found some aquamarine, which is a beryl mineral. I believe aquamarine sits at about an 8 to an 8.5, 9. So this is also scratchable with the steel nail, but it's slightly more durable than the quartz. All right. Now we're up into the really, really tough stuff. This is an example of corundum, which is generally what is represented as the number 9. You start to need some professional equipment to start getting into these ones. Generally, that's a masonry drill bit, which sits at an 8.5 on Mohs, and that's why it is able to scratch everything up to a 9 and a 10. So I found this. I suppose I can use this as the example for 7 and 8, but I found this, and we'll see if... So you can see that it's just not doing anything to the surface. And when you get up to these really, really tough, durable materials, what's going to be the indicator is just the lack of a scratch rather than what you're able to scratch it with. So a 9 and a 10, they're just essentially, they're indestructible almost, unless you've got some professional grade lapidary equipment to utilize. This should scratch our aquamarine here. Might not because it's polished. There we go. I don't know if you guys could catch that. Aquamarine's pretty durable, but it should still be scratchable. Scratching just a little bit. But yeah, that kind of sits in an 8.5, 9 range anyway. This one, this quartz should scratch with the drill bit. You can see I made a little divot there. So yes, Mohs hardness is a really useful way to identify your materials, whether that's outside in the field if you're finding stuff, or if you've got something in your collection that you are not quite sure of. That's a really good way to to test and find out what material it's made out of is through using Mohs Hardness Scale. I'll show you guys this little thing I made one more time. So like we went over, your fingernail will be able to scratch 2, 1, and 2. A copper penny will be able to scratch a 3, or in like a calcite sort of material. A knife or a glass plate should be able to scratch a 4 or a 5. The 5 will just be a little bit more difficult, but it will still happen. A steel nail will be able to scratch a 6, so something like a K feldspar family material, like an orthoclase or a labradorite. And a masonry drill bit you can use to scratch, masonry drill bit you can use to scratch an 8 and a 7. And then above that, you really just need some industrial grade stuff. So, if you have any questions, please let us know. I'd love to dig deeper into anything that anyone's wondering about. I really enjoy testing all of these things in the field just because it's kind of a fun, tactile way to figure out what you're working with. I know that I've been out rockhounding and I haven't quite been sure what I've had, so I've had to take out, a penny or a nail. Find that quartz and calcite can often look really similar, so if you try to scratch it and it scratches pretty easy, then it's probably a calcite versus a quartz. But yeah, this is a really useful tool in the field or at home that anyone can do. It's really accessible. You just need a couple of different types of materials. So we'll be back in our next video to talk about luster and how you can determine differences in materials based on the luster. So yeah. Is there anything else as hard as a diamond? I think there probably is. I would have to fact check myself. I know that there are a couple things that approach the hardness of a diamond. Like garnet is used a lot in industrial saws and things. So I know that it can get pretty tough, like a 9.5. But like I said, the scale's logarithmic, so it increases tenfold. So when you get up to a 9, to get to a 10, you have to multiply the 9 by 10. So it's quite a lot. The differences between the 1 and the 2 and the 3 are like this big compared to the difference between an 8, a 9, and a 10. So that just gets to be a pretty big leap between the different levels. Really, I think there are like a couple of things that are harder than a diamond. I don't know that they're naturally occurring. And they might be a bit obscure as well. Graphene, it looks like, is pretty tough. So I think that might be the hardest mineral in the world is graphene. So that one beats out diamond. And there might be a couple of others on there. But generally diamond is what you see on that Mohs Hardness scale. And that's kind of the standard for a level 10 on that scale. But yeah, if we have any more questions, please let me know. I think this video is going to be up on YouTube. So leave it in the comments if you'd like us to talk about anything else relating to this one, and then we'll be back to discuss Leicester in a minute. Thanks so much. Can never remember how to turn these off.